look up. Look way up. I plunge toward the Earth in the power tower. The tallest ride on the planet. I climb high into the atmosphere and look into deep space with the most powerful telescope on Earth. Oh, wow.
Alicia, you're moving 300 tons of steel by hand.
And I check out a 700-pound bodysuit. Astronauts use it to practice for space.
You ready to go?
I think so.
Okay, what's going on?
Woohoo! Charlie fulfilled his lifelong dream of dropping stuff off buildings while actually getting paid for it.
I love my job.
Woohoo! It's popular mechanics for kids. Zero gravity.
Hi, I'm Alicia.
Hi, and I'm Tyler, and we're trying to spot clouds that are shaped like things.
Reindeer.
Cotton ball.
Anvil.
Cotton ball.
Umbrella.
Cotton ball.
Lawnmower.
Sweater, made from cotton, all bundled up into a ball.
You really need to work on your imagination.
Oh, yeah? Well, you're just a big cotton ball.
Just tell them why we're here.
Everything we do on this show can be summed up in 6 little words. What goes up must come down. Airplanes, baseballs, clouds, everything. Alicia, can I borrow your ring?
Yep. That's right. And you may also be interested to know that heavier things don't necessarily fall faster than lighter things. See?
In space, though, things float, just like in water. That's why astronauts practice in water. Let's say you're an astronaut, preparing for a repair mission in space. How on earth do you train?
With one of these. It's called a hard suit, and it cost over $1 million. Oops, I hope I didn't dent it, because I'm supposed to be trying it out soon.
Oh, don't worry, Alicia. This suit can take a lot more pressure than that.
I'm in Vancouver, British Columbia, at Cyanic Hard Suits. Steve is a submarine pilot and trains people to work in these suits.
Before astronauts go outside the spacecraft to do work, like fixing the Hubble Space Telescope, they go through months of underwater practice down here on Earth. Why underwater? Because in water, you can make a person seem weightless.
To be weightless in the water like an astronaut, we adjust the weights on the back of the suit to achieve neutral buoyancy.
Neutral buoyancy is when you don't sink or float upwards. You kind of hover under the water.
Want to try it?
Yeah. Really deep in here.
Yes. A lot of room in there. We'll hardly see you. Okay, we'll get ready to put the dome. You ready to go?
I think so.
Okay, dome's going on. Okay, Alicia, you ready to go?
I can't really see out. Aw, I'm not tall enough to operate the suit. What a drag. I want to be able to do this. But don't worry, you'll still get to see this suit in action. Someone else will do it. It's his first time ever in the suit, so don't expect a smooth ride.
Okay, when you go in the water, you'll feel yourself get slightly buoyant.
The person inside can actually drive this suit because it has propellers.
What we want you to do is take the pin out of the shackle and then screw the pin right back in the shackle. Can you do that?
This is how astronauts rehearse for working in space. They have to be able to go outside the spacecraft and fix things like satellites. It's hard to be coordinated when you're weightless and you're wearing a big suit.
That's it. That's it. Lock onto that center part.
This is how he controls the claw on the inside.
That's it. Now you can spin that thing.
He did it! But then he loses control of his suit.
You must have accidentally pushed the thruster controls on the foot pads.
Ouch, look at him go! He's like a ball in a pinball machine. Maybe it's a good thing I couldn't try it out. Imagine blasting 240 feet into the air, then getting shot like a bullet to the ground. I did it, you can too. We take on gravity, coming up on BNK. This is no regular airplane. It is the KC-135 NASA zero-gravity trainer. It flies in an arc pattern, kind of like being on a roller coaster. When the plane begins to fall, future astronauts can experience up to 25 seconds of zero gravity. That's because they're free falling, which means they're falling at the same rate as the plane, so they seem to float. It looks like fun, but after flying up and down 40 times in a 3-hour training session, it's no wonder they nicknamed it the Vomit Comet. This is what it's like to burst a water balloon in a zero-gravity environment.
Taking the time to look into the mysteries of the universe.
That's right. And I find that gazing into the immense vastness of space reminds me of how small and insignificant Alicia really is.
And conversely, it reminds me of how big Tyler is not.
That may be true, but once I read an entire issue of Astronomy magazine. So stand back and watch the master at work. Oh! It's a giant asteroid headed straight for Earth! Everyone run, we're all gonna die! We're all gonna fall! Look at him run!
Millions of years ago, when dinosaurs ruled the Earth, it's believed that a giant asteroid crashed into the Earth with such great force it destroyed most of the animals on the planet, including the dinosaurs.
If it happened before, chances are it will happen again. That's why I'm on my way to the Keck Observatory.
If a giant asteroid or comet is on a collision course for Earth,
This would be a good place to see it.
the Keck Observatory has the biggest and most powerful telescope in the world. It's built on top of this inactive volcano. It's so high up that you have to go there in stages.
If I went straight up without getting used to the thinner air, I'd get dizzy, slur my words, lose my memory, and maybe even faint. So I'm taking a break halfway up. It's called acclimatizing. This is one of the best sights in the world for observing the universe.
We're above the clouds, so the sky is really clear. At night, light from the cities doesn't reach here, and there's no dust pollution in the atmosphere.
This is Andy Perella. He's gonna show me why this is the most powerful telescope in the world.
What makes this the world's most powerful telescope is this gigantic mirror. It's the biggest in the world. It's impossible to make one single mirror that huge, so they built it in pieces. Each piece is bigger than a person.
This one big mirror is actually made up of 36 smaller mirrors put together like a honeycomb.
The bigger your mirror, the more light you can gather, and the fainter the object you can see, like very distant galaxies or distant asteroids that may be headed our way.
This telescope is so big, it's 8 stories high and weighs 300 tons. How do you move it in the position that you want to see?
Usually astronomers use computers to control the Keck telescope, but it's so finely balanced that you can actually push it by hand. Would you like to give it a try?
Yeah.
Go ahead. Lean into it real hard at first.
Oh, wow.
Alicia, you're moving 300 tons of steel by hand.
That's totally awesome. So when light from a distant object, like a planet or asteroid, comes through this tube, it hits the mirror, which is shaped like a giant contact lens.
Which reflects the light to a second smaller mirror and then sends it to a digital camera, which then records the image.
Miles away at observatory headquarters, astronomers watch as images from space come in.
Today we're looking at a galaxy that's actually orbiting our own Milky Way galaxy.
Regular telescopes show close-ups of planets you can see every night in your backyard when you look up into the sky, like Saturn, Venus, or the moon. This telescope looks into deep space.
Right, it's so powerful that you could actually see a 100-watt light bulb on Mars.
Well, what's the chances of an asteroid or comet hitting the Earth?
Actually, it's fairly rare, but recently we found one that passed between the Earth and the moon.
Well, how far in advance did you find out about this?
We actually only found out the day after it happened.
The day after?
Mm-hmm. Because it's actually fairly hard to find these things because they're so faint.
Whoa, an asteroid came close to destroying the Earth and we didn't even see it until the next day? I think we need more telescopes like this watching the skies. Stay tuned for Charlie's experiment where he gets the drop. On gravity.
Another one. I love my job.
Woohoo! That's coming up. The Hubble Space Telescope gives astronomers a better view of the universe than any telescope on Earth. That's because it takes pictures of the stars from above our cloudy atmosphere. The Space Telescope is actually a really fancy satellite. It's as big as a school bus and can circle the Earth in about an hour and a half. Right now, tiny particles from outer space are piercing right through your body. They are neutrinos. Inside the sun's core, 200 trillion neutrinos are born every second. They shoot out into space, reaching the Earth in minutes. They are so tiny, they pass through you, your dog, buildings, the whole planet Earth. You don't notice them, but that doesn't mean they have no effect. If they weigh anything at all, their combined gravitational pull could cause the universe to collapse in a final big crunch. Don't worry yet. It wouldn't be for another couple of billion years.
Hi, I'm Charlie. You ever have one of those days where you just felt like doing nothing? This reminds me of inertia. Inertia says that an object at rest will stay at rest until a force makes it move. Oh, if you don't start Charlie's experiment right now, you're fired. No. I'm actually kind of glad that happened. Ow. An object at rest needs a force to move it, and a force that affects us every day is good old gravity. Gravity is the attraction between any two objects. Of course, you're not going to notice the attraction unless one of the objects has a whole lot of mass, like, say, the Earth. Now, the Earth is so heavy that it pulls all of the objects on it towards its center. Gravity seems to be working today. And that's a good thing, because without it, we'd all float right off the Earth. And so would the air, which is bad if you want to breathe. Since gravity gives objects their weight, it's obvious that if you drop two objects of different weights, the heavier one will fall faster. It's obvious. Obviously wrong. They fall at the same speed. But don't feel embarrassed. A lot of smart people thought heavier objects fell faster. Well, Aristotle, for instance, and he was no dummy. He thought that if an object weighed twice as much, it'd fall twice as fast. But then Galileo came along and showed all these folks they were wrong. He did that a lot. Galileo declared, everything takes the same time to fall, whatever its mass. But what if you had a parachute? Woohoo! Galileo was right. Objects do fall at the same rate, unless air creates some resistance. Air creates friction, and friction slows things down. How? On the moon, there's no air to slow things down, so you'd think the same object would fall faster. But it falls slower. That's because the moon is smaller than the Earth, so it doesn't pull as hard on objects. But if you want to slow your fall on Earth, your best friend is air. Woohoo! The flat piece of paper falls slower than, say, the same piece of paper crumbled up. Because the flat paper covers a greater surface area, and the air helps the paper resist gravity's mighty pull, just like with the parachute. Woohoo! Without friction and air resistance, skydiving would just be falling and screaming! Now, I have nothing against Galileo, but I think there's something he didn't try dropping that would be a lot more fun. Another one. I love my job. Woohoo! Woohoo!
I'm at Cedar Point Amusement Park in Sandusky, Ohio, and I'm here to try a very special ride. Working for PMK has its advantages, like no lineups.
Oh, hi, Tyler. I've been waiting on you.
Hi, this is Monty. He knows this ride better than anyone. He built it.
Well, here it is, Tyler, the Power Tower, one of the world's largest rides of its kind in the world.
Wow, look at it. This 300-foot-tall monster has 4 towers. 2 space shots where the riders are blasted up into the sky, and 2 turbo drops where the riders are shot down the tower at over 55 miles per hour or 90 kilometers per hour. I'm doing the turbo drop.
This is the control room. The power tower works with compressed air. The people are either riding up or down on a burst of air.
That's correct. Essentially, we have a pressurized tank of air that's staged and ready to move the car up and down. It works a lot like a water pistol. You pull the trigger on a water pistol, water comes out the end of the gun. And the same way here, these guys pull the trigger and air squirts out and moves the car up or down the tower. You ready to go ride it?
You bet! Power Tower challenges one of the fundamental laws of nature, gravity. We feel the pull of gravity every day. The Earth pulls on us. That's what keeps our feet on the ground. But on this ride, I'll experience weightlessness, just like astronauts do in space.
Yes, but it'll be pretty quick, Tyler, so don't blink.
For a split second, it'll be like standing in an elevator when the cable suddenly snaps. Gravity pulls down on you and holds you to the elevator's floor. But if the elevator suddenly dropped, you would stop feeling your weight on the floor. You would seem to be floating. This ride is more extreme than a falling elevator because it shoots you like a bullet down toward the ground.
There's a pressurized system that fires you earthward at minus 1.7 Gs.
That means we won't feel weightlessness for long. Instead, it'll feel like gravity is reversed. On this ride, a 100-pound person will weigh 70 pounds in an upward direction, pushing up against the safety restraint. in 3 seconds! Woo!
I could do this forever and never ever get bored of it.
That was a lot of fun. And as I said, working for PMK has its advantages. And I think I'm going to use those advantages and try out some other rides. If you'll excuse me.
Well, that's all the time we have today for PMK.
It's nice to get a chance to finally relax. You know, they called this show Zero Gravity, but they should have called it New Ways to Make Yourself Puke.
Yeah.
Gravity's not something I'll ever take for granted again.
Sorry.
Oh.
Charlie, stop dropping things. The show is over.